in this world of LPG, which stands for liberalization, privatization and globalization, we have one success mantra for success for any industry, and that is the best quality at cheapest price. Now when we talk of price, so it consists of manpower cost, maintenance cost and a lot of overheads, and maintenance cost is one of the key factor while deciding the product cost. Now every maintenance man has basically three key objectives to fulfill. First objective is he has to make the machine available for production around the year, because so that the machine is always available, so that we can control the productivity of the plant. That is the first function he has to perform. Then the second function we can talk of is the cost optimization. So he has to maintain his machinery in the allocated budgetary constraints, the budgets which has been allotted to him, so he has to maintain the machines in those allocated budgets. So that is also important, because it decides the cost of the product. And there is nail biting competition. If your cost is higher, then you will be out of the market. So that is the second important thing which a maintenance man has to perform. Then third one is, which is very important, is the SHE factor, which is safety, health and environment. So he has to ensure the safety, health and environment of that particular industry. That is also important for a maintenance man. So here we can see one of the common situation in any industry in which some load is being handled by the electrical operative crane. Now here you can see that one of the rotor is being lowering down in some housing. Now because the housing is some restricted area, so we have to be in very slow motion. So slow hoisting is being done here because it is going in some restricted area. Now there is one warning here that whenever you are lowering some heavy load, then you don't be yourself under the load. Then here you can see that if there is any slippage of brake or if any failure of brake, then this whole load, which might weigh around 100-200 tons, it will suddenly get down, so that there can be some mechanical damage, there can be some deformation, and the whole efforts which has been laid down by the different departments goes in vain. So that is the biggest problem, and it has happened because of the brake only. The video which we just saw, we saw a major failure of brake in the video. So the huge rotor which was being put down in the stator, so suddenly it got slipped and the entire body got deformed. So the efforts of so many people, the productivity, the cost, suddenly we lost a big amount of money, productivity and all those things, and that was merely because of poor setting of brake. So here we can see one of the typical brakes we are normally using in most of the industries in material handling, and this brake is known as double disc type electromagnetic brake, which is normally used in most of the industry. Now here we can see its operation. It's an instantaneous brake, because when I put it and suddenly it stops. So this is the thing which is required in most of the material handling equipment. Instantaneous braking means wherever I want to hold the job, I should stop it then and there. It should not slip. That what happened in the video. This is a brake which is widely used in most of the industry for material handling equipments. So this is electromagnetic double disc type brake, which is normally closed type. So here you can see we have one plate stamp here on the top of this base plate. So here we have OEM, that is original equipment manufacturer recommendation of the brake setting, how the brake should set. Now we have to be very specific while setting this brake, looking at the recommendation given by the OEM. Now here we are having one base plate. This is my base plate, in which we have the coils, electrical coil. Then I have this armature plate. Then we have this brake liner, or it is also called as friction disc. And this one is the dummy plate, and this is again friction disc, and this is my base plate. So these are the different parts we are having in this brake, and this is the compression spring, which plays a pivotal role in the braking phenomena. This is very important. So we cannot play with this spring. So if suppose if the spring gets deformed, then we have to replace it with the original spring. We cannot play with these pairs. And this one is the dummy spring, these two, and this base plate is now connected to the motor. So we have, as per the specification plate, we have two specific setting in the brake. One is the air gap is to be checked whether it is in the range as given by the OEM is 0.5 to 1 millimeter. So whether it is in between 0.5 to 1 or not. And second one is the length of the spring. So length has to be 36 millimeter specific. All these three compression springs must have clear length of 36 millimeter. No deviation from that. So we have to be very specific in that. So let us see how we can check it. It is clearly mentioned here what should be the air gap and what should be the length of these three compression springs, and which are very important. So let us see how this air gap is checked. Just drag it in and out here. So this is how this air gap is checked, and it has to be uniform both the sides, otherwise there will be difference in the setting. So the same gap has to be there on other side. So we have here the vernier caliper, and I have set it to 36 millimeter, which you can see here in the vernier caliper. This is 36 millimeter as recommended by the original equipment manufacturer. So let us see whether the length of the spring is 36 millimeter or not. So we can just have a look at it. So it is 36 millimeter, right? So we have to ensure that all the springs have been set to this 36 millimeter. That is important. So here we understood how a brake should be set in any industrial application, because this is more important, because the human life is at stake. So we have to be very specific, and we have to strictly follow the OEM recommendations. So as we just saw, so we have to check the air gap, whether it is within the range of 0.5 and 1 millimeter or not, and second one is the length of the spring. So if these two things are okay, then your brake is perfectly okay, no problem.